Hello everyone, welcome back to my YouTube channel Big Data Analytics with Hadoop, Spark, Python and R. My name is Pratik Shirbhate and today we will be learning about the architecture of Hadoop 2.0. In the previous video we have seen the architecture of Hadoop 1.0. So when we have Hadoop 1.0, why Hadoop 2.0 was introduced? So what are the limitations of Hadoop 1.0? So we have seen that all the metadata of the data nodes and the file system was stored in name node. So what happens if the name node gets failed? And we already have discussed that even though we have a secondary name node, it cannot replace the name node in case of failure. So what exactly happens if the name node gets failed? So if name node gets failed, it loses the metadata, and if your client wants to retrieve data from your data nodes, and there is no way you can retrieve the data since nobody knows where the data is stored. And also we have seen that whenever a client want to submit a job, the first point of contact of client was a job tracker. So what happens if the multiple clients submits their jobs or multiple jobs are getting submitted? So in that case job tracker gets overloaded and the performance of the system ultimately gets reduced. And also Hadoop 1.0 supports only map reduced jobs. So even if you are submitting jobs in Python, Ruby, Perl or the language of your preference, it in the backend it gets converted into map reduce and then the job used to get run. So to overcome this limitation, Hadoop 2.0 was introduced. In Hadoop 2.0, along with the MapReduce and HDFS, we also have a YARN. YARN stands for Yet Another Resource Negotiator. It's a cluster resource management and also other data processing frameworks apart from MapReduce is also introduced in Hadoop 2.0. So as I explained earlier, in Hadoop 1.0, a name node manages all the activities of a cluster and there used to be only single name node per cluster. So yarn was introduced in order to take care of the scalability and the reliability of Hadoop. Yarn brings significant performance improvement for some other applications. It supports additional processing models and implements a more flexible execution engine. It was created by separating the processing engine and the resource management capabilities of a MapReduce as it was implemented in Hadoop 1.0. Yarn is often also called as the operating system of a Hadoop because it is responsible for managing and monitoring work loads, maintaining a multi-tenant environment, implementing security controls, and managing high availability features of Hadoop. So, like an operating system on a server, Yarn is designed to allow multiple diverse user applications to run on multi-tenant platform. In Hadoop 1.0, user had the option of writing MapReduce program in Java, in Python, or the language of their choices. A data transformation language. So, and it is to convert that languages into a MapReduce program before getting submitted to the client. I mean, before submitted to the job tracker. So Yarn supports multiple processing models in addition to MapReduce. One of the most significant benefit of this is that we are no longer limited to working with the input output intensive high latency MapReduce framework. So this is a typical architecture of Hadoop 2.0. So the name node is splitted into active name node and the standby name node. So the standby name node is always ready to take place of the active name node in case of its failure. So active name node has the information of all the metadata stored in the form of fs table, and the activities carried out by the active name node are stored in the form of edit logs, which is continuously gets supplied to the standby name node. So in addition to this active name node and the standby name node, we also have the secondary name node, which was also available in the Hadoop 1.0. So to take care of the job tracker's responsibility, we have a resource manager. So in which the resource manager is split into two tasks. One is the scheduler, and the second is the application manager. So whenever client submits a job, the first point of contact of client now becomes the resource manager, and then the resource manager gets connected to the active name node, and it fetches the information where exactly the file is located. So in case of writing HDFS write operation, if the client wants to upload the file or upload the information to the HDFS, so the resource manager gets connected with the application manager, which ultimately uh, takes the information from the application master. So here the data node is splitted into three parts. One is node manager, application master, and the container. Container actually stores the data, whereas node manager gives the heartbeat, or it gives the status of the data node. uh, Excuse me, it gives the status of the data node to the resource manager, whereas the application master gives the status of the jobs which are currently running on the data node to the resource manager. So to brief out what I have explained in the previous slide, the fundamental idea of introducing yarn or the MapReduce 2 is to split up the major functionalities of the job tracker. So we stated that there are two things. One is the scheduler, and the second is the application master. The resource manager and uh, per node slave, which is also called as a node manager, form the data computation framework. The resource manager manages resources among all the applications in the system. The resource manager has two main components: scheduler and application manager. The application manager is responsible for accepting job submission, negotiating the first container for executing the application specific application master, and provides the service for restarting the application master container on failure. The scheduler is responsible for allocating resources to the various running applications subject to familiar constraints of capacities, queries, etc. The node manager is the per machine framework agent who is responsible for containers, monitoring their response, monitoring their resource usage such as CPU, memory, disk, network, and reporting the same to the resource manager or scheduler. The per application master has the responsibility of negotiating appropriate resource containers from the scheduler, tracking their status and monitoring their progress. Container incorporates elements such as memory, CPU, disk, and network, etc. I hope you enjoyed the video. Please do like, comment, and subscribe my YouTube channel, and hope to see you in the next video. Thank you.